Welcome to Board Bytes. In today's question, we have a rectangular loop whose dimensions are 2 cm by 5 cm. It is carrying a current of 1 ampere as shown, and there is a straight conductor wire at a distance of 1 cm from it. We have been asked to calculate the torque acting on the loop and the magnitude and direction of force on the loop due to the current carrying conductor. We know that tau is equal to vector m cross vector b. Now, according to the right hand thumb rule, when current is flowing in this wire, then the magnetic field in the wire on the loop, according to right hand thumb rule, if you look at like this, the magnetic field is perpendicular going inside. You can see it clearly like this, and the area vector of this wire is also downwards. Therefore, when I apply mb sin theta, I get theta is equal to 0 degree, and therefore tau will be 0. No torque will act on the loop because sin 0 is equal to 0. Then we come to the force. When I am talking about force, then I have to consider this wire and this wire and the force between this wire and this wire over here. For the other two arms of the loop, there will be no force. Now, for the first and second loop, the formula for force is mu naught by 4 pi into 2 I1 I2 by R per unit length. So we'll write F1 is equal to mu naught by 4 pi into 2, I1 is 4 ampere, I2 is 1 ampere, upon the distance between them, as you can see, is 1 centimeter. So 1 into 10 is for minus 2 per unit length multiplied by 5 for the length of the wire. And in this case, we find that the currents are flowing in the same direction. So we can say this is an attractive force. For the wire this and the arm this, we find that F2 will be equal to mu naught by 4 pi into, currents are same, 4 and 1, but the distance is now 1 plus 2, that is equal to 3 centimeter per unit length. Length is also same. Then we find F net. In this case, the two wires are in opposite direction. Current flowing in them are in opposite direction. So the force is repulsive. Therefore, F net will be F1 minus F2. We know F1 will be greater because the distance is smaller in F1. So now we put the values that is given in the question. For mu naught by 4 pi, we write 10 raised to the minus 7, then 2, this is I1, this is I2 per unit length. So this is the length of the wire, and 10 raised to the minus 2 I have taken outside from the denominator here because they are in centimeters and we convert into meters. So after putting these values, we get the 2 10 raised to the minus 2 gets cancelled, and we have 10 raised to the minus 7 multiplied by 80, 2 4 is 8, 8 5 is 40 into 2 by 3. This is equal to 80 upon 3 into 10 raised to the minus 7, which gives us 26.66 Newton on rounding off. This will be our answer.